Hello everyone, my name is Ton Snowart. I'm an application engineer at Luceda Photonics, and in this webinar I will talk about closing the gap between PIC designers and foundries, more specifically about DRC in PIC design and Luceda DRC. Everyone can see my slides before I get started?
Yes.
Okay. So an outline of the webinar. So first I will talk a bit about Luceda Photonics itself, and I will talk about the challenges inside DRC. And then I will introduce our new product, Luceda DRC. So first an introduction, then show actually the workflow and some features and advanced settings. In the end, we will have a look inside the code, inside our visualizer, and run DRC on an actual application example. And in the end, I will end with a conclusion. So first about Luceda Photonics. Luceda Photonics was born in 2014 from the Belgian photonics ecosystem. And our vision is to help photonic IC designers enjoy the same first-time right experience as the electronic IC designers. And we want to do that by helping them set up a flexible and efficient PIC design flow. Our head office is in Belgium. Then we also have an office in Shanghai. And we have an official partner, Spark Photonics, which is a design house. Then we also have two resellers, one in Japan and one in Taiwan. So we help photonic and IC designers enjoy the same first-time right, having the same first-time right experience as electronic IC designers, and we do that by introducing our Luceda Photonics design platform. And this platform introduces a flow that goes from component design to circuit design to design validation until the end of the design flow. Having one platform allows us to reduce design errors, to leverage one standard language, and to with this flow we are also able to design manufacturable PICs and improve the time to market. Here you can see our actual platform. On the left side you can see the design kits that we offer. We offer silicon design kits for different material platforms as well, like silicon nitride, indium phosphide, aluminum oxide, and lithium niobate. And we also offer a few assembly and testing PDKs. Luceda IPCIS is our core product, and this is the flow that brings you from component design to circuit design, design validation, until your eventual tape out. Some features are that we have our own simulation engine. We have a schematic capture, which is IPCIS canvas. You could do netlist extraction, functional verification, and also export your GDS at the end. Next to Luceda IPCIS, our core product, we also offer Luceda DRC, which is a new product that I will talk about more in particular now in this webinar. And then also AWG Designer is one of our products specifically to design AWGs. And then we have IP Manager, Circuit Analyzer. We also offer links with existing software specifically for device simulation of your components. And also a link with Siemens and a link with OptiWave. That's a bit about the introduction. Now I will start talking about DRC and the challenges that come with it. So before going into actual DRC, I want to talk a bit about a design approach, which is called design for manufacturing. So let's think of the following scenario. We have a big designer that wants to tape out to a foundry. He gets a PDK and he starts working on this application, on this layout and simulation and so on. Once he finishes his design and he's happy with the results, he wants to tape out to the foundry and he sends over his design. The foundry receives a design and he's looking, is this design actually manufacturable? And for that, the circuit needs to comply to a few design rules. And these design rules are rules about the minimum feature size, about the pattern density, the spacing between waveguides and angles, and so on. And the Foundry concludes that there's still a lot to be changed before it can actually manufacture it. So it sends a lot of questions. Can you change this? Can you change that? In this scenario, the PIC designer did not take a design for manufacturing approach. If the PIC designer would already have taken the manufacturing process into mind while designing the circuit, and if he would have ensured that it already complied to the design rules of the Foundry, then after submission, he would be able to eliminate a lot of the communication with the Foundry, and the Foundry would be able to fabricate the chip within the project deadline. This design for manufacturing approach is needed for a PIC designer, and a PIC designer actually requires a verification step in order to take this approach. And this verification step is where DRC comes in. So DRC is short for design rule check, and a design rule check basically validates the compliance with all Foundry specified rules. As output, after the check is done, you get a DRC report in which you have a list of design violations detected by the engine. A design rule check bridges the actual gap between the design intent of the designer and the Foundry constraints. To run a DRC check, we need a specific rule deck and we need a DRC engine. And it can be both done from the designer side and from the Foundry side. And in the end, it's always there's always communication between the Foundry and the designers to negotiate on which of the violations should we approve, which of the violations can be waived or need to be fixed. Here is a list of common DRC rules that can occur. This is not a complete list. One of them is minimum feature size. You have to make sure that all the feature size meets the Foundry's minimum requirements. Then rules about spacing between waveguides, rules about overlap of layers and enclosure of layers. Then there's density rules that validates pattern uniformity. And then important is that there are no acute angles, because this could cause performance degradation or it could cause defects. And the same for snapping errors. Snapping errors can lead to artifacts during mask generation, so they need to be avoided and are also common DRC violations. With Luceda IPCIS, we offer tools to actually fix these design errors. In particular, we offer tools to fix snapping errors, to patch acute angles, and to do dummy filling for density violations. And we also have a detection tool to detect general design violations, to detect general acute angles, for example. These are not based on Foundry rules, so there's a big difference with the actual DRC that I was discussing before. In general, there are some common frustrations about DRC, and it's mainly because unexpected issues can come up before the tape-out deadline. Often the designer is not able to run a DRC check by himself and needs to rely on the Foundry to run the check. And in that case, it is possible that there are a lot of errors that the designer needs to fix in a short amount of time. Also, it's hard to fix all the errors in one iteration, because fixed errors can also create new errors. And usually multiple revision cycles are required, which creates lots of repeated back and forth communication between PIC designers and Foundries, which can lead to stress and increased costs, and even maybe a tape-out deadline that's missed. So with that into mind, I would like to introduce Luceda DRC, which is a new product that we've offered since March. Luceda DRC, with this new tool, you are able to verify your PICs before the tape-out by running a DRC check. And you can run a DRC check on any component layout, circuit layout, or even on any GDS file. When you run the check, you get a DRC report with all the violations. Afterwards, you can debug them and you can rerun them until you end up with a DRC clean layout. This DRC check is integrated inside your environment. So inside our visualizing tool, we have a DRC button that runs a DRC check, and this means that we have a single environment for design and verification of your circuit. We also use our own native DRC engine to run the check. Having Luceda DRC enables you to adapt your design flow as a designer. Let's first have a look at the traditional flow, design flow. We start with component design, then we do sub-circuit design, get to circuit design, until we have finished circuits. Then we send it over to the foundry, we get a DRC report, usually with lots of errors that we need to fix, so we need to redesign a lot. Then we send it again, get another report, until we finally have a DRC clean layout that can be that can go to tape out. With Luceda DRC, we offer an adaptation of your design flow. We make sure that the verification step can happen a lot earlier in the process. For example, when you're designing your components, we make sure that you can already run a DRC check on your components so that you can have DRC clean components to create your sub-circuits. Then the same thing for the sub-circuits. You can run a DRC check, create DRC clean sub-circuits to build your entire top-level circuit. And this allows you to early detect DRC errors, which leads to faster development cycles. And in the end, you are able to deliver a DRC clean design to the foundry, so no back and forth communication between designers and foundries needs to occur. If you look from a foundry perspective, from a fab perspective, when designers are using Luceda DRC to verify their layout, foundries are able to maintain the standardized rule enforcement, and they are also able to safeguard process integrity. Also, the designs that they receive are already automatically validated against their process rules. On top of that, foundries can receive support from Luceda to develop their own decks. These are some of the foundries, 4 foundries that which we already offer a deck for. So Silterra, AMF, Tower, and Ligentech. And this list will grow, and you can find an updated list on our website anytime. So with Luceda DRC, we aim to close the gap between PIC designers and foundries. The PIC designers are able to submit their design with confidence, while the foundries are able to receive DRC clean designs that they can fabricate. So in this way, a lot of the communication can be eliminated and the gap can be closed. Now I will have a look a bit more inside the products. So let's have a look inside the visualizer, what you need to do to actually run the DRC. So I press the DRC button, which is over here, and then you get a DRC configuration in which you need to select your rule deck from the foundry. The rule deck you can find inside the PDK, and we always have a tech files folder in which you can find a rule file that you need to select. Then you can make some adjustments to the configuration. You can choose which top cell, you can choose the rule groups and the threads. I'll go into detail later about that. And you can press Run DRC. After you press Run DRC, your full layout undergoes a DRC check, and you can get a DRC report at the left side of your of the visualizer, at the right side. And inside this DRC report, you can see all the rules that have been violated. You can see an explanation about the rule, and you can highlight the rules which you want, the violations that you want to view, and also you can scan through them easily. That's all there is to running the actual check. Now I can talk a bit about the features and more advanced settings. So in the DRC configuration window, you can select a specific cell, a specific subcell as well, instead of selecting your top cell by doing hierarchy navigation. Then you can also select different groups. So in order to have faster iterations of your DC checks, you can choose which rules you want to run. And at last, you can also control the amount of system resource allocation that you use to actually run your DRC check by adjusting the threads. Another thing is that with our DRC engine, you can perform density checks in order to meet the foundry requirements for pattern uniformity. And what our engine does, it already implements dummy filling in the background, and this dummy filling will be foundry validated, and it will be based on values from the PDK. So a designer does not need to worry about dummy filling. And if a designer wants to do some custom dummy filling himself, we also have a tool available for that in IPCIS. We can run DRC on any GDS file. So Luceda DRC is a standalone product, which means that you don't need an IPCIS license. You need a Luceda DRC license, and you can run it on any GDS file also without an IPCIS license. When you don't have an IPCIS license, you don't have access to the visualizer, so you can't run from the visualizer, but you are able to run from codes using these methods over here. The run DRC method requires a GDS file, the rule file, and the top cell name. And since you can't visualize the actual violations, it is possible to visualize them using a different GDS viewer, such as K-Layout. The outputs of the DRC can then be visualized inside K-Layouts. So now you can, so that you can run DRC on any GDS file. That was about the settings, and that was about the product. Now I will give an application, give us a demo on an actual application example inside our visualizer, and we will run DRC on a programmable photonic circuits. We will fix a violation until we have DRC clean layouts that can be submitted to the Foundry. So for that, I will go into the visualizer. Over here, you can see our visualizer. We have a few buttons here. This is our circuit. We can see the hierarchy, the cell hierarchy. We can show or hide labels, show or hide the grip, different ports, anchors, connector specs. You can do snap to grid to detect snapping errors. You can also save this layout to an HTML file. And the last button is the most important one for this webinar, is the Run DRC button. So imagine you receive this layout from your colleague, and he knows that you have Luceda DRC, so he asks you, can you run DRC and fix all the errors? What you do is you select your rule file, which I take out of the BDK, a SciFab rule file. Then the top cell is the full circuit. This time I will run all the groups, and I just press Run DRC. Then we can see here a DRC report with all the errors that appear. So in this case, we can see that 3 of the rules inside the deck are violated, and you can see the amount of violations as well. If you open the window, you can scroll to them separately as well. Here as well for the other violations. By clicking on it, you highlight every one of them. And if you want to click on a separate one, you can only highlight this one. It's also possible to run DRC on an actual unit. So this now I'm running it on a smaller unit of my circuit. And now you can see how we run DRC for a subcell. Going back, it will open up in a different tab. Going back to our circuits, I will now go over all of the errors and we'll fix them by using tools in IPGIS. So in the first rule, it seems that it always occurs in the directional coupler P cell. So, and if you have a closer look at one of the errors, it seems that it is due to an acute angle. So what we need to do is we need to patch this angle, and this area shows the amount of area that needs to be patched in order to meet the foundry requirements. For that, I will go to PyCharm and I will create a new directional coupler P cell. This directional coupler P cell inherits from the P cell I was using before, but it adds a stubbing. So I will use the stub acute angles method and choose the waveguide elements and the layers that needs to generate a stub for the acute angles. Using this directional coupler inside my PPC unit, which is used to create my full square, which is then used to create a full routed circuit, I will be able to generate the next layout, which is this layout. First, you can see here the directional coupler with this stopped acute angles. And this is the actual circuit where all the directional couplers now have stopped angles. So we can now run DRC on this circuit as well. We can see in the report now that the rule about the acute angle disappears. Now there's only 2 rules left to solve. We can have a look first here at the metal 2 layer rule. So here we can see an explanation about the rule. The minimum width needs to be 1 micrometer on metal 2 layer. So if I have a look at one of the violations, I can see, okay, maybe I go to my layers and I show only the metal 2 layer because that's where the error will be. And now I can have a look and I see that indeed 1 micrometer goes here from 105 to 106 and it's below 1 micrometer. So we need to create vias that are bigger in order to meet the foundry requirements. For that, I will create a bigger via cell, but I will make sure that the via array still has the same area. So this is created here, where we create a custom via cell. And in this custom via cell, in my layout method, I create a rectangle for my metal 2 layer, which here is has a certain geometry of 1 micrometer box size. So it's a rectangle with 1 micrometer box size for both of the length and width. And I add it to my layouts. And then I will make my via array using this via and remaining the same box size that I had for my original via array. Running this code, I get into following circuit with this custom via that I've created, with now 1 micrometer width and length. That is put into this via array. That is put into this circuit. Running DRC. Should now resolve the error, the violation about the metal 2 layer. We see there's only one rule left to solve. And this is for the metal 1 layer. Also, the minimum width needs to be 1 micrometer. We can see, if you look at the violations, that it's all about this one wire that's connected to this bond pad. It's a very thin wire, and it's too thin for an actual common ground. So what we will do is we will create a variable, which is the width of our bond pads, and we will make a trace template, or we will change the trace template so that the width now is the same width as the bond pad. For that, we go into the routed class, where we create all of our wires. Here I created a parameter, the width of the common ground, which equals the size of the metal 1 layer inside our bond pad. So because we are creating a parametric circuit, now any bond pad that I choose, this common ground will always have the same width. Creating the wire, we need a trace template. So we create a wire template, and then we give it a certain width, which is the bond pad width, and the layer is, of course, our metal 1 layer. Afterwards, we get the following circuit, where we can see now that the metal layer is has the same width as our bond pad. This should solve the last issue. Again, have a look. See DRC finished, and now there's no violations left. So now this design is ready to be sent out to the foundry for tape out. So this was running it from the visualizer. What I will show now is I will go into the same situation, but in this situation, we don't have an IPCIS license. We received this GDS file from our colleague, and he's asking, can you run DRC on this with Luceda DRC? We don't have an IPCIS license in this hypothetical case, but we can run DRC from code. And for that, we need to import Luceda DRC as DRC. And this code does the actual DRC run. We select the GDS file. We select the rule file, which can be found inside the PDK. And then we select the name of our top cell, which we want to run DRC on. So for now, I will comment this one out, and I will just run the DRC. So we can see that it created a results file. And this is a marker database that can be opened in K-layouts. Since we don't have access to the visualizer, we are able to open it in K-layouts. Running it with this function, which gives you the same GDS file and the marker database that is the output of our run DRC functionality, we can now go into K-layouts and have a look at the results that our engine detected. Here you can see again the 3 rules that we fixed very shortly. If you have a look at the more specific one, this was the one with the angles that we patched. Then here, this is the one with the very small width of the common grounds, and over here you can see the small bump paths. So in this way, you are also able to visualize the violations that are that came out of our engine. I will now go back to the slides. To go over a conclusion about our products. So with Luceda DRC, we aim to close the gap between designers and foundries, and it has the following benefits for the designers. You can leverage a native DRC engine, which is integrated in your own environment. You can adapt your design flow by shifting your verification to the early stages, and you can tape out with confidence. For Foundries, it has the benefit that you can receive verified DRC clean GDS submissions, which will reduce customer support and which will eliminate a lot of back and forth communication with designers. So thank you very much for listening. Are there any questions about this?
Hi, this is Alan Yang from GDMS. I have a few questions about this. You mentioned that for your examples, you showed using a SciFab rules. In the case of the foundries that you support, who is responsible for providing the rules files? Is it Luceda or the foundry?
So I think we developed the actual decks together with the foundry. We actually developed the decks. Yeah.
Okay. And then specifically relating to Tower Jazz, can you say anything about if all processes available to Tower Jazz, I guess, we're talking photonics, so we're talking PH18. Are all PH18 processes have their separate rules that are checked, or is it just one rule set for all PH18?
Yeah, I'm sorry, I don't, I'm not able to answer that question yet, but I will
Why
note
not?
it down, and I will get back to you because I need to ask the developers who are working on this deck. I don't have the
Okay.
information right now. Sorry about that. I see Salim raised his hand.
Hi, good morning. Can you hear me?
Yes.
Okay, perfect. Thanks. So I want to ask about the API from Visual Studio. Does it support all the functionality of the DRC, same as in the Luceda platform as well? That's the first thing. Could you comment also on the licensing or the license of the DRC, like in comparison to the license of the Luceda environment as well? And finally, like for the DRC decks, could you comment on like how to make them from a foundry perspective, like that a foundry that has not used Luceda yet, would it be easy? Could you comment a little bit on the process, basically?
Okay. So the first question was about the API inside the visualizer.
in
Yeah.
VS Code.
So if the Visual Studio, you can basically just get all the functionality. Like for example,
Yes.
can you also apply the density checks and things like that?
Yes. Any IDE you use, you can just import the packages from Luceda, and all the functionality will be in there. If I understand correctly. You mean with Visual Studio, using Visual Studio instead of PyCharm?
Yeah, exactly. Yeah.
Yeah. So indeed, you will have the same functionality available to you. I got lost
Also
track.
licensing as well.
Maybe I could answer this question. So you're asking about licensing for the DRC because yes, it is a separate module from IPKIS. And so yes, we're happy to talk about that. If you would like to learn more about the licensing, we can discuss it in a follow-up meeting. But you do need a separate license for it. But of course, much like IPKIS, you can have both floating and node-locked variations of the license.
Perfect. Thank you.
I think there still was a third question that you had.
Yes, just a quick question about DRC decks. Making the DRC decks, like, could you comment a little bit about the process? Because if it's not too time consuming to make from the foundry.
To develop the actual decks. How time consuming is to develop the actual decks for the foundries? Is that
Exactly? Yeah.
that really depends on the actual PDK, on how many layers and how many rules they have. Well, I think for small PDKs it can go very fast, but for if there are like 100 layers with 200 different rules, it will take a few weeks to develop those decks. Yes, I think. Does that answer your question?
Yes, perfect. Thanks a lot for the answers.
Thanks. Are any other questions?
Sorry, Torben, there's a couple of questions in the chat. The first one is from Negin. And the question is not about DRC, but in your Python code, how do you automate the routing between components? What's the function for this?
Okay, so this is about IPKIS. So we have connectors to create the routing between two different ports that automatically generate a waveguide connection. We also have bundle connections that can create a bundle between a set of ports and another set of ports. It's also possible to create your own waveguides if you want to create something very custom. I don't know how deep I should go into this. Is there any specific question you have about this?
Hi,
Maybe if
can
you
you hear
can.
me?
Yes.
Yeah, sorry. So previously I used Python to do some routing, and I used I think it was the function was route bundle, and the way it was connecting and doing the routing was not optimized. It was like it was not connecting the closest ports to each other. So I wanted to make sure how you do that.
So you were having an issue with the bundle connector functionality.
Yes, yeah.
It's,
So it's like the routing was not the most optimized routing.
Yeah, well, I think it's quite a specific question. You can send support ticket and we can have a look on what the actual problem is. But if a bundle routing does not seem to have the best optimal connections, maybe you could try do separate connectors. I don't know how many ports you need to connect with each other. Have you tried doing separate connectors too?
No, if you can show me how to do that, that would be great. But if it's
Okay.
not possible, that's also okay. Thank you.
You can send out a support ticket to support@lucedaphotonics.com, and we'll be happy to help you with any questions you have about that. Just send out over your code, and then we can have a look at the actual routing and how to optimize it.
Okay, thank you.
Okay, the next question in the chat, Toon, was DRC. This is from Bhaskar Abrahiraman. He said, thanks for your talk. DRC can be computationally intensive. Is your engine efficient?
Yes, so I think you're referring to the speed of the engine.
Yes.
It is quite fast, comparable to K-layout, for example. We are a bit faster than K-layout. We also tested with other standards for which we have quite comparable speed. So the engine, I think, in terms of speed, is quite good, quite fast. It's hard to put an actual number to this, or because we tested for different circuits for different decks, but of course there's always these results can fluctuate a bit.
Yes, there was another question in the chat, which I think maybe has been picked up, but maybe for the general audience. So if users require support for the DRC, how does that happen? Who should they contact?
And that will be for the designers, probably.
Yes, yeah, for the people using the DRC tool.
Yes, so any questions can always be sent over to support@lucedaphotonics.com, and we really try to answer within the day, at least for a preliminary answer to look into this. So we are really active on this channel. So if you have any questions, we try to help you as fast as possible.
Okay. There was a question from Ewald. Is it possible to write our own rules, or are they encrypted, undocumented?
So if you want to write your own deck, you can we can set something up together. You can contact us and we can see what's possible. It is possible to encrypt your decks. It is also possible to keep it to keep all the rules visible. If you have interest in doing such a service or in developing such a deck, you can also contact us and we can see what's possible.
Okay. Just one comment that was also posted in the chat from Luceda. It was in reference to the first question from Alan, sorry, at the beginning. It was about the distribution of the DRC deck and the processors at Tower. And so, yes, we will be supporting multiple variants of the Tower processes, and the decks will be available in the PDKs. And will often be shipped by the foundries themselves. Okay. And there's another question in the chat from Katayun. How does density checking work? Is it foundry specific?
Yes, so density checks are part of the rules inside the actual rule deck. So you can select them or you can not select them, but it works the same way as the other checks. Is it foundry specific? Yes, because the engine actually implements dummy filling based on foundry requirements. So dummy filling is automatically added to the to your design. I hope that answers the question. Yeah.
Okay, there's 2 minutes left. If there are any final questions, you can always put it in the chat or unmute yourself. Okay.
Okay.
See some claps, a greeting to your Cecils. We'll pass that on indeed. And so, yes, if you would like to learn more about Luceda DRC or any of our tools, please feel free to reach out to us at info@Luceda Photonics. And if you have questions specifically about use as a user of IPKIS, you can contact us as support anytime for help. Okay, so I think we can stop this webinar now. We wish you all a pleasant evening, afternoon, morning, depending on where you're based. Thank you very much.
Thank you very much. Bye.
Thanks all.